Alright guys, let's go ahead and start with finding extrema. So we're going to find this extrema on this closed interval. I don't know why that's so far away. So same idea as what we've been doing in the past few videos. We're going to go ahead and start by taking the derivative. So y prime will be equal to 6x squared minus 6. Then we take that and we set it equal to 0. Solve for x, so I can divide out the 6 here, which means that I can reduce this even more and factor it even more. So x is equal to plus or minus 1. So we should be kind of used to doing that by now. Alright. I'm going to type up this theorem because it's been a little difficult to write today. So we're going to let f be continuous on the closed interval AB. And we're going to let it be differentiable on the open interval A comma B. So we're saying that it exists between A and B, so A and B are included there, filled in circles, but we're going to say it's differentiable between those 2 points. We don't know if it's specifically differentiable at A or B. We're going to say those points don't exist when we take the derivative of it because it'll make my life harder. So if f of A is equal to f of B, then there is at least one number C in AB such that f prime of C is 0. So if I plug in both my 2 endpoints and I see that they're exactly the same, then someplace in there's going to be either a minimum or a maximum. And when that happens at either the minimum or the maximum, we're going to have that horizontal tangent line, and we're going to set it equal to 0 and just find that C. And then we're going to find that x value. Okay, so first things first. We have to check to make sure that my 2 endpoints exist, that they're the same value. So let's take a look. If I plug in 1, so I have 1 squared minus 3 times 1 plus 2. That ends up, that ends up going to be 0. And then if I plug in 2 and I have 2 squared minus 3 times 2 plus 2, what does that give me? Well, that's also 0. So that first part checks out. They both equal the same point. Okay, so that means I either have a minimum up there or a maximum. Excuse me. A minimum down there or a maximum up here. Someplace. We don't know. We're going to figure it out. So then the second step tells me that I'm going to go ahead and take the derivative of this function. So when I take the derivative, I get 2x minus 3. I'm going to go ahead and set that function equal to 0 and solve for that x value. So that x value is 3 halves, or 3 over 2. So someplace, or excuse me, so at the point 1.5 or 3 halves, there's a maximum or a minimum going on. Go ahead and start this next one on your own. We'll check up here in a second to see if we agree on what's going on. Alright guys, you should come up with the same x values. We have points at 0, -1, and 1. If you don't get those, check your factoring. When you factor out at this point here, you can take out a 4x, which would leave you 4x parentheses x squared minus 1. And that x squared minus 1 is the difference of two squares, so therefore you can continue factoring it out. And that's how you get the 3 answers. Okay, so this one is so that we don't have to try and read my handwriting, because we all know that that goes over real well. Okay, a secant line is a line drawn through 2 points on a curve. And this theorem talks about the secant line compared to the tangent line. So it says that if f is continuous on A to B, and it's differentiable, it's the same kind of idea of what we said above, then there's a number c that exists in there, such that if I plug in these values, I should be able to find that value. So you write that down. I'll wait. Alright, so this is what it's saying. If we take a look, we talked about how here's my f and my b. If they hit the same value, this is not the best point, but if they hit some value, then that means that that point of C would have to be the same slope as the secant line, because the secant line would go through both of them. Since they would be at the same point, they'd end up having the same slope, and since they have the same slope, we know that the derivative of one would have to be the same as the other, because parallel lines have the same slope. Alright, so what does that mean moving forward? What that means is we're going to find these x values a slightly different way than what we had just done in the beginning. So using this next formula, it tells me I take the f of my right endpoint. So in this case, the f of 1. I'm going to subtract that by the f of my left endpoint, which is -5. And I'm going to take that whole thing divided by my values. So in this case, 1 minus my -5. So it kind of goes in the same order. So the top is when you plug it in, the bottom is just the numbers. So if I plug in 1 above, I get the value of 4. And when I plug in -5 above, I get the value of -50. Notice here I still have subtraction, so that turns into addition because of negative, so that turns into 54 divided by 6, which gives me 9. So what that's saying is that at that c value, so f prime, the derivative of my function, not of x, is 9. So that y value is 9 in this case. So they're both going to hit the value of 9. In the example before, we went to the y value of 8. In the example before, we went to the y value of 0. But this function would not be as fun to solve for. So that's why we're doing it this method. So then I would set it, what I do next, according to this theorem, is I take the derivative of my function, so the derivative of this would give me 3x squared plus 6x, and that would be equal to that value of 9. So I move over that 9. I go ahead and I factor, because I'm still trying to find x values. I get 3x and x. Well, I need to multiply to a negative 27, add a 6. So I'm going to use 9 and 9 and negative 3. So I want the negative 3. Oh, come on. And the positive 9. So when I solve for those, I should get negative 3, and I should get 1. So 2 different ways of solving for your x values here. So let's go ahead and try this next one on our own. So then you should get your x value of negative 1/2. Alright, that's all I got for you.